Good afternoon. My name is David Kulhavy. I'm the Lacey Hunt Professor of Forestry here in the Arthur Temple College of Forestry and Agriculture at Stephen F. Austin State University at Nacogdoches, Texas. And what we're going to do for a few minutes today is talk to you about the use of pictometry and where we use pictometry in natural resource management. We're going to talk about it where we use it in our teaching curriculum across different classes within our curriculum, including GIS, which is Geographic Information Systems, in landscape ecology, in remote sensing of the environment, and also in forest insects and diseases. We're going to show you some of the techniques that we've been using over the past year and a half when we first got the imagery, and show you how we can use it to measure elevation, slopes, and these other things. So I'd like to introduce my colleague here, Dr. Yikai Han.
I'm also with the College of Forestry and Agriculture, and I teach GIS, Geographic Information System, and Spatial Sciences. And I'm involved in this program is that it is a new technology for us to measure heights. And as a forester, we are interested in trees. And how do we measure trees? Of course, we measure the diameter and we measure the height. Diameter is easy. You just walk up to a tree and you measure the diameter. But for height, and the most accurate way is to cut it down, lay it on the ground, and out of tape. But it's not the way to do the business. And we cannot hire monkeys and going up to the top and roll down the rope. Of course not. So there are some traditional techniques, and all of them and can achieve different levels of accuracy. And with this new technology, pictometry, then you can measure a tree height without going to a tree. That would be amazing.
One other thing that we want to talk about with pictometry in the measuring the height and all that is that we can compare this to other methods, and we've shown that this is extremely accurate. We have two different levels of pictometry here. One is called the neighborhood, which is 4-inch resolution pictometry, and the second is called community pictometry, which is at 9-inch resolution. And these are taken at oblique angles, 4 different oblique angles, so you can meld these together into a three-dimensional area that Dr. Dan Unger is going to show you.
Hi, just a quick introduction to who I am. As Dr. Kulhavy said, Dr. Daniel Unger, a professor of spatial science here at SFA, and I specialize mainly in application of remotely sensed imagery to map, quantify, and basically just figure out what the real-world numbers are for our natural resources. And what I'm going to demonstrate today here on screen is how accurate pictometry can be and actually calculate the actual height of a tree out in the woods to actually minimize cost, make it more efficient, just make it more useful tool to save a lot of time, cost, and money, and get highly accurate measurements that we can actually use in our management plan. So with that, I'm just going to make a quick demonstration on the height measurement of an actual tree outside, sitting inside. Now this is actually the online pictometry interface. It basically looks like that, but I'm just basically going to show you today a really quick measurement tool. When you load it up, it actually looks like this, and I'm going to zoom out a little bit. And basically right now we're looking at an oblique angle, which means non-nadir, not looking straight down. So we can zoom in and zoom out. And this is actually the campus of Stephen F. Austin State University. This is actually the College of Forestry right here. And I'm going to zoom in a little bit. And this little red box indicates where you're going to take your measurements from. And right now we're in an oblique angle, but if you click down here, which for me is a little bit more useful than the oblique, which is what most people are used to seeing from an aerial photograph from an historical perspective. But pictometry is a little bit different. And I'm going to zoom out and actually look for a tree to measure the height of here. And there's the College of Forestry. We're going to measure a pine tree about right there. I'm just going to go look for a tree to show you how efficient this can actually be. I'm going to zoom in a little bit. And then, since I want to measure the height of the tree, I need the angle or the oblique view. And I'm going to look at this from the west perspective. I just click this button real simply. And I can zoom in. I'm going to look for an easy tree. There we go. I'm going to zoom in a little bit more so I can see a little bit better. And the beauty of pictometry is because you can actually see the side. We've got a high resolution data set coming online. You can actually see the side of the feature, which is critical in height determination. And it's really, really easy, and it's very fast, very efficient. Say, for instance, this tree was 50 miles from where you want to be. It would take hours, a lot of gas, cost, and money to do that. But we're going to do this in just seconds. I'm going to take this height tool, identify the base of the tree, drag up to the top of the tree, where you perceive the top of the tree to be, release the mouse button, I have now calculated the height of that pine tree to be 98.04 feet in seconds. Very efficient, respect to time and cost. And we just recently got an article accepted for publishing in the Journal of Forestry that talks about this, and it's equally as accurate as going out in the field. There's no statistical difference between this measurement, this height measurement, and going out into the field. So with that, it's that simple, it's that straightforward, and it's an amazing tool, and will probably revolutionize tree height measurement inside the urban interface within, I'm thinking, the next 2, 3, 5 years.
Once we have the height measurements of the trees, we can take that height measurement and put it into an online database within Pictometry. And once it's in the online database with Pictometry, this can be exported as a KML file off to Google Earth or to ArcGIS 10.2 that we use here within the college. So we just want to make that point.
That's something.
Okay, and now we are trying to tell you how accurate it is, how easy it is to get tree heights without going to the field. But you might have this big question. Is that accurate? How confident you are? Of course, we have to do some experimental tests. So we randomly selected a number of trees that are representing the trees on the SFA campus. And then for each tree, we take measurements of pictometry, and then we send our students going to the field with a height pole, reach out to the very top of the tree to get the exact measurement of the tree. And then with a good number of sample, and we are able to run some statistical analysis and to verify there any significant difference between pictometry measured height and the real on-site measurement of tree height.
I think what's so important about this is we can take a real-world application and put this right into a classroom. We can also take that real-world application and put it into research. So we're actually using this to measure an endangered plant species also. So it's not just one measurement in forestry, but a number of different measurements.